So you did an ed puzzle on Friday, I think it was, on finding the volume of these, and we're going to have a look at this particular one. And we said to find the volume of a prism, and this is a hexagonal prism. Can you all see my screen okay? Yep, okay, good. To find the volume of any prism, we do it by, who can remember? Who can remember? Yeah, good. The area of the cross section multiplied by the height. Okay, and somebody else this time, who can tell me what shape is the cross section of this? Yep, good, Josh. So the area of the cross section is just the hexagon. We have to work out that first, okay? So that's like the area of the top or the area of the bottom. And how do we work out the area then of a hexagon? Somebody else? Yes. Good, Imogen. So we make it into a little, we divide it up into little triangles. Actually, and what I'll do is, just to kind of make this hopefully a bit clearer, I draw one. So hexagon has got 6 sides. Okay, so imagine that is our base. Okay, so this is the cross section. We are told that this length is 7, and we're told that this distance is 5. Okay, so who can tell me how do you work out the area of a triangle? Yep, base times height divided by 2. So in this case, it's 5 times 7 divided by 2, which is 5 sevens or 35. 35 divided by 2 is 17.5, okay? Now that's the area of just this one little triangle. How many triangles make up this entire hexagon? 6, yeah, because there's 6 sides, so there's 6 triangles. So we have to do our 17.5 times by 6, and I'm going to do it on my calculator here. 17.5 times 6 is 105. Okay, so the area of our hexagon of the cross section is 105, and so to work out the volume, it's going to be 105 multiplied by the height. Now, the height is the length of our 3D shape, okay? Which is, in this case, 15. Thank you, Magnus. So I can put that in, 105 multiplied by and that gives me 1575. And if we're working in volume, it's going to be centimeters cubed. Okay. Any questions about that? No, it's hopefully it's not too bad. And just remember, so it's the cross section and then multiplied by the height. Okay, it doesn't really matter if you call this the height or the length. And again, it's the same as if I was to take this shape. Let me copy it. If I paste it down here. It doesn't matter which way up the shape is, of course. You know, the cross section is still this hexagon. And it's still my cross section. It doesn't matter how the shape is placed. And the height of the shape is still you know, the length, and you can think of it as the height is the distance from the, you know, one of the cross sections to the other one. As you can see, we've got a hexagon at one end, and we've got another hexagon at the opposite end. And the height, or the length, is just the distance between them. Okay? All good?